Hello everyone. Okay, so in this video, we are looking at the graphs of derived functions. But before we get into nitty gritty, let's just recap, right, on certain graphs and their derivatives. So, if I have a cubic graph, remember that's a power of 3, the derived form, well, the first derivative will be a quadratic graph because it would be an x squared power. If I have a quadratic graph, so it has an x to the power 2, my derived form would be a linear graph because it would just be a pair of x. And then if I have a linear graph, then my derived form would just be a constant a, or just a constant, or i.e. the slope of that line. So we just have to remember that if it's a cubic goes to a quadratic goes to a linear, and a linear goes to a constant, i.e. a horizontal line. So we need to be familiar with first of all, what the degree of our derived function is going to be, but also we need to be familiar now how to give it a good sketch, right? So we know a lot of this already. So below is an example of a graph showing the relationship between f of x, its first derivative, and its second derivative. So this blue function is my function f of x. My red function is my first derivative, and this kind of teal function here is my second derivative. So what do we know about the relationship between these graphs? Well, I find maximum minimum points by saying the first derivative equals 0. But what does that mean, the first derivative equals 0? Well, that means where the first derivative crosses the x-axis. So wherever I have maximum and minimum points, right, that is where my derived function crosses the x-axis. So if I have a quadratic or a cubic and I have maximum point, I can automatically know where my derived function is going to cross. Now I need to find out the shape of my graph, if it's increasing or decreasing. So we notice here in my derived function, all the values up until this one are above the y-axis. So i.e. my first derivative is greater than 0. If my first derivative is greater than 0, that means my function is increasing. And that makes sense because look at my blue function here. It is increasing. See, it is increasing here up until that same point. Then looky here. Then it's decreasing between these 2 points, which makes sense because this function, because my first derivative is under the x-axis, i.e. all the values here are negative, right? Therefore, it is decreasing. And then finally, we're back to increasing again because all my values of my first derivative here now are above y. Therefore, they're positive. Therefore, my function then is starting to increase from here on out just again. Right? So that is important. We need to know when we're sketching graphs. And then also the final thing here is the inflection point. We know the inflection point is when, the point of inflection is when the second derivative equals 0. So i.e. when my second derivative crosses the x-axis and it crosses here, and would you have it, the inflection point is right above it. So let's look at this example here now. So y is equal to f of x. Write down the range of values for which f, the first derivative, equals 0. Well, the first derivative equals 0. That happens at maximum minimum points. So there's a maximum point there. There is a minimum. Ding, 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 ding. So x is roughly going to be equal to minus 1.1. And x is going to roughly be equal to 2.5. Right? So my derivative is going to cross at this point and this point. Find where f of x is greater than 0. So where is my function increasing? Well, it is increasing up until that point. So it is increasing when x is less than minus 1.1 and when x is greater than 2.2. And finally, find where my first derivative is less than 0. So where my function is decreasing. My function is decreasing between them two values there. So between the minus 1.1 and 2.5. Minus 1.1 x and 2.5. That is where my function is. So 1.2, 1.1, same thing, right? So hence sketch the graph of the derivative of the function. So looky here, these are my roots. So I'm crossing these 2 points. So up until this point, I am positive. So my quadratic is like this. It's above the y-axis. Then between these 2 points, it is negative. But then at this point again, it's positive again because my function is back increasing. And there is my sketch of the first derivative. And it makes sense. This is a cubic, and then my first derivative is a quadratic. Let's look at some exam questions here. So the graph below shows p of x and l of x. There are two values of x in the domain for which the first derivative of p is equal to the first derivative of l. So let's do it now. Let's look at my derivative of p first. So we know this looks to be maybe some sort of a cubic. But the root of my derivative function is going to be where the function is at its maximum and minimum. That is going to be around here and around here. That is the roots of it. Now, my function is decreasing from that point. So it's decreasing. Then, you look here. My function now is increasing. So my derivative is going to be above the x-axis, right? And then it's back to decreasing again from here down, which makes sense, right? Because my function is negative, my derived function is negative. So there is p of x. Now L of x. So we're dealing with a linear function here. And since it's a linear function, the first derivative is just going to be the slope. And the slope is rise over run. So my rise is 2, my run is 1, 2, 3, 4. 4. So it is going to be a half. So my first derivative is going to be a half, which is roughly around here. So L of x is there. So my two graphs roughly intersect at around 2 and 7.2. Right? So x equals 2 and x equals 7.2. There are my two rough answers there. Let's look at this one here. The graph of a cubic function is shown in the first diagram below. The maximum value of p of x in the domain is 1, and the first derivative evaluated at x is 0 is minus 3, where the first derivative of p is the derivative of p of x. So using this information, sketch the derivative of p of x. So I have a point here. When x is 0, my function is minus 3, so it's down here. Stunning. It has a root at minus 1, and it will have a root at minus 3. So it's literally going to be that. That is what my function is going to look like there. A cubic to a quadratic. Finally, last one here. We're now matching up functions, right? and a derivative. So I'm just going to use different highlighter colors. So looking at my function, my cubic function here, well, cubic goes to a quadratic, so it'll be this one here. Then a quadratic goes to a linear term. Let's look at it again here. This one now seems to be trigonometric. So this seems to be a sine function. So sine goes to cosine. There it goes there. And there we go. We're now to negative sine. Okay, what about this one? This one seems to be a logarithmic function. Well, that seems to be here. And then here again, another logarithmic function. And then finally, have here k, which is a quadratic. Well, a quadratic first derivative is a line, and then a linear derivative is a constant, or a horizontal line. And that's them all matched there. And in part B, just asks for one row in the table, explain your choice of first derivatives and second derivative. So you easily can say for FDII, cubic, quadratic, linear. And that's there. Anyway, that is all on derived functions, really. I hope this video was some help to you, and I'll catch you guys later. Bye.